Hey everybody, Lars here. Get ready, because this is the video. This is the final review video from Big Bad Unit 3. And this is the one where we're going to talk about modularity and libraries. And what we're going to do is we're going to real quick look at some import stuff. But then after we're done with that, I am going to do my very own homework assignment. And we are going to create a file, read numbers from that file, and then use functions that we store in our own libraries in order to look at some of those numbers. So it is very similar to somebody else's homework. Yes? Yes? Yes. All right. Let's start out by looking at some Python. I already got some stuff ready for us. And I think I'm going to use this little scratch thing. And as you can see, I just created a little list, and I printed the sum of the list. If we take a look at that, we see that it's 489. But let's say that I wanted to, let's say A equals sum of my list, and we wanted to get the square root of that number. Well, how could I do that? I could say B equals square root of A, and when I run that, boom, it blows up because it doesn't know where square root is. It is not defined. Well, I happen to know that there is a square root function in a place called the math library. So you may be saying to yourself, and I know you're not because you read the slides and you read the book and you know what's going on, but you may say to yourself, what or where is the math library? So what I'm going to do, and I'm going to Google to show you how easy this is, just say Python docs standard library. Boom. The Python standard library. And you'll see, you can go to the Python documentation for the library, all of the different libraries that Python has for you to use in your code. The story with the libraries are this. If Python loaded all of this code every time that it ran, it would be huge in memory. It would be completely unwieldy and a big Leviathan. So, kind of like what C did before. If you learn later on when we get more experience and we learn more about Python, you're going to learn that Python really is C. It's a wrapper around the C programming language. But anyway, as usual, I digress. These libraries are here for us to use, but we have to tell Python that we want to use them in order to use them. As we can see down here, number 9, we can go to math library. And if there's ceiling, that's nice, factorial. We may see a little bit of that in the next unit. And if I keep going down, 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 I see there's indeed a square root function in the math library. So let's go in our Python program and use it. First thing I'm going to do, all you C programmers out there who are used to your include statements, this is similar. I usually start my programs by importing the libraries I want to use. So I'm just going to type import math. You can see our friend Idle made import orange, that we know it's a keyword. And I'm going to import from the math library. And I'm just going to say import math because I am going to tell this function where to go to get that particular function. So if I import the math library and then I say B equals go run the math.square root function to give me the square root of A. So I'm going to get the square root of 489, whatever that is. I think. Let's run it. And it does nothing. Why does it do nothing? Because I didn't print it. It's fruitful, and I did not print it, but I did capture it in that variable at least. All right, and there we go. There's 22.11 named, and that's kind of messy. So I think I'm going to do this. I'm going to say C equals math dot ceiling B. And then we're going to print C. And as you can see, ceiling just rounds up. Now, if I wanted to, I could say floor, and it would round down because floor is another function in the math library. Math is not the only library. If I want to, I can import more than one. With my import line, I will import the statistics library, and instead of math.floor, let's get rid of all of this and say that B equals, actually, you know what, print Statistics dot mean of my list. And if you give a list to the mean function and the stats library, you will see that the mean of that list is 40.75. And then if you wanted to, you could even math.ceiling, wrap it all in a ceiling call, so that 40.75 becomes 41. Tom Seaver, Met fans. So that's how we do that as far as importing libraries and then using the functions that come in the libraries. If you want to know what those functions are, you go to the documentation and you can look in the math library and see all of the different functions you can use. I can go back to the table of contents and I can go to statistics and I can learn about there's mean, there's median, there's none of that. One of the nice things about the documentation, click mean, takes you right to it, tells you how to use it. Okay. Another cool thing, I think I allude to it in the slides, all of these libraries, for you to use them, the software is loaded and it's on your hard drive. So the code that does all of that is on your hard drive. You can go look at it if you want. Maybe at the end we'll go look at it. I don't want to go get lost in the weeds right now, but if you want to learn how Python actually does all these things, you can go look at the code. It's no mystery, sitting right there on your hard drive, which is kind of neat. Kind of a neat way to learn and kind of a neat way to do things. You can always go to Google and say Python Standard Library, make sure you have the right version. This is 3.5, but if we wanted 3.4, we could go grab it and it wouldn't be a big deal. Okay? Not a lot of differences between 3.4 and, why is it doing that? 3.4 and 3.5, so you got no worries. There's one last thing I'm going to do, and I don't recommend it because I don't do it this way, but I'm going to show you anyway. I'm going to say from math import, what did we use? Ceil, and from statistics import mean. And when I do that, I associate the library with the function, so I don't have to tell Python where to go find it anymore. So now I can just use ceiling and mean as if they were regular functions already in my program, because I tell it where to go and where to look here. And you'll see if I save that and run it, I will get the same answer. Okay? Personally, and I often say this, and I've said this in other videos, I prefer just to do the import and then put the library name in front of the function, because later when you become a programmer and you are dealing with big programs, when I say big, I don't mean bazillions of lines of code, but if you have a couple hundred lines of code and you're down near the bottom of a program and all of a sudden you see a function call, you don't know if it's homegrown, you don't know if it comes from a library, you don't know where it comes from. Well, if somebody's reading my code, they know what library it's coming from because I tell them. I put the full path of the libraries in when I use functions from the standard library. A little bit old school, I guess, a little old-fashioned, but I think it makes things more readable, and being readable is a big thing in Python, so I like to do it that way. I'll be honest with you, if you do it this way, I'm not going to penalize you. People have their own styles. They like to code in certain ways. Either way is going to be fine for me as far as seeing it on a quiz or seeing it used in a program. So don't freak out and think you have to do it my way. I do it the old-fashioned way because if someone's reading my code, I want them to know that what I'm doing is coming from the standard library. Okay? All right. Enough of that. You now know how to use the standard library, import libraries, use functions, blah, blah, blah. Next week, we're going to get more into third-party libraries like Matplotlib and NumPy, SciPy, even Pygame. The next class, July 25th, I think it is, we're going to have some fun because I'm going to show you some Pygame stuff. Pygame is a third-party library that helps you make video games. And I'm going to show you some of the stuff that me and the Video Game Club have done. But, again, I digress. As always, I'm going to take this scratch1.py. I'm going to put it up on the web for you. Not exactly the most intriguing code you're ever going to see, but we need to move on, because what I'm going to do now is I'm going to do something similar to your homework. And what I do, and what I've done in the past, and I'm just going to do it again, is I give myself a little homework assignment. And starting right now, 8:39 p.m. on June 29th, right in front of you, I am going to code up my homework assignment. What my homework assignment, I think, is going to be is to take a file of 1,000 random numbers and create a program that detects and accumulates all of the numbers that are palindromes. And for those of you who are unaware, a palindrome is something that reads the same way forward as it does backward. Similar to your homework assignment, we are going to read from a file, and I am going to use a function that is in a custom library that I'm going to import at the beginning of a main program and use to detect my palindromes. All right? So, first thing we're going to do, nothing in my hands, nothing up my sleeves. I am going to go to one of my favorite places. If you ever become a computer science instructor, you will be best friends with random.org, because it's where we go get the numbers. Click on numbers, click on integers, and I'm going to say generate 1,000 integers. Each integer should have a value. I'm going to say 10,000. And format in, I'm going to say 10 columns. And get me some numbers. Look at that. Isn't that cool? Got me some random numbers. Now watch this. I am going to highlight the first one right there. Ooh, that's a lot of numbers. Then I'm going to come down here, grab that last 9. I'm going to Control C to copy. And then what I'm going to do is I'm going to grab numpad and I'm going to paste. Look at that. I got all my numbers right there. And I'm going to save as, and I'm going to go, I have a Python Data Science, Summer, Unit 3, UVV3, and I'm going to save this as rnums.txt. Save. All right, so if I'm not mistaken, I now have that file. Got that file thing licked. So Python data files, Summer, Unit 3. There we go, and I have my 2 programs, which you're going to see in a minute. But now I also have rnums. So now we have a file with 1,000 random numbers in it. So let's get started. I already created the shells for these things. So I have a library that I'm going to use, and it's called tools.py. So let's do the library first. We can deal with the reading of the file and other things along those lines later. I need a function that detects whether something is a palindrome. So I'm going to define, and what I'm going to do is in lowercase I'll say is, uppercase P, pal, and what I would usually do is spell palindrome and call it is palindrome, but I'm not going to make it that long because I'm going to call it a lot. I'm just going to call it is pal. And isPal needs to take an argument, which is a string. And I believe in the past I've called it ppal for potential palindrome. And then I'm going to get started. The reason I do palindromes is because Python has a trick. And I'm going to teach you this trick. It's kind of neat. If you have a string in one line, you can figure out if something is a palindrome. Okay? Think about strings. Think about back when we did string manipulation. Okay? Think about slicing. And watch me work. If ppal is equal to ppal, but I'm going to slice it beginning to end, but go backwards. Okay? Colon to go down, and that's it. Think about it. From the beginning to the end, but going backwards is what? It's that string backwards. So if the string is equal to itself backwards, that's a definition of a palindrome. So if that's the case, I'm going to return true. Okay? Else return false. It's a binary thing. You're either palindrome or you're not a palindrome. Okay? So look at that. I am now here in my library. I'm going to get rid of this code in a second. I will test it. I will say A is equal to everybody's favorite little palindrome, race car. And then I'm going to say print is pal A. And see what we get. Hey, it says true. All right, so it says race car's true. Now, it may say true all the time because it's broken. Let's put those 7s in there and make it a little lopsided. And now it says false. I like it. Okay, let's say 113311. That is a palindrome. Same backwards as it is forward. And it says true. Now, if I put a few weird numbers in the middle there, it says false. Okay, I think we're in good shape. I think we are in very good shape. One more for S and G, yes. All right, we're in very good shape. So I'm pretty sure my palindrome function works well. I'm going to get rid of this little test code right here. And I'm going to do one more thing just for us, just so you can see it. I'm going to create a variable called gooden. I'm going to make it equal to 16. Okay? And I'm just going to let it sit there. I am going to save so that everything is saved in this file. I have a function called isPal, and I have a variable called gooden, and that's it. That's tools.py. I'm going to save it. Okay? No code, just a function definition and one variable definition. That's it. Okay? Let's get out of here. Now, I go back and I have a main program. I'm calling it U3 Unit 3 Video 3.py. Okay? You know I'm going to put it up afterwards. In this program, I want to read in the file. I want to clean my data so I get my numbers in a list that I can iterate over. And then, using my isPal function, I'm going to test to see if the items in that list are palindromes. And if they are, I will print them. I'll click a counter, and I'll accumulate them so that I can print a sum at the end and tell you how many there were. All right? This is my little homework assignment. So I am going to start by doing a comment, and I'm going to say file IO read our nums.txt. So what do I want to do? I'm going to take a string variable, and I'm going to give it the file name. So I'm going to use that in my very next line, which is going to be f equals open, and I will say in file. And I will open the in file for reading. So that should take care of that. Then I'm going to say data equals f.read. And because I am always a good citizen, I am going to say f.close and close my file. Now, if I'm not mistaken, we're out of the file IO business. File IO is good that way, especially in Python. You just read it, grab in all the data, close it, boom, done. So now, and actually we'll do this incrementally. I will print data for you to show you what it looks like, and hopefully we get it. Look at that. And I got my columns. See how that went in? Now, I've said this in other videos. I'm going to say it in this video. We're not regular Joes, okay? We're not sitting at home eating Cheetos, playing scratch-offs. We're Python programmers. So we don't see columns of numbers here, all right? We see number, tab, number, tab, number, tab, all the way down the line until we get here, and then we see a new line, okay? Number, tab, number, tab, number, tab, all the way down the line, tab, tab, then there's a new line, all right? It's important because we're about to use that information to parse our data and get us closer to checking things out. So what do I want to do now? I want to clean that data. I want to get that data in a list and put it in a format that I can iterate over. So the first thing I'm going to do is I'm going to say data is equal to data.replace. All right, you got any idea what I'm going to do for the replace? It's not that clever, but it's a little clever. I need a delimiter to tell the split to look for in order to put this number in a list. But I've got two different things separating my numbers. I got tabs in here, but after 10 digits, I've got a new line here. So I think what I want to do is I want to make everything the same. So I'm going to take the new lines and I'm going to change them to tabs. That way the only thing separating the numbers is going to be the tabs. So what do I want to do? I want to replace \ns with what? \t's. It's that simple. Okay? Then after I do this, and I'll print it for you to show you. Now I don't have any more new lines. See? The only thing stopping me here is the way idle displays numbers in Windows. If I could go all the way across that screen, that would be a single line because there are no new lines, right? It's all tabs. So that, for our purposes, is perfect because what we want to do now is we're going to say data equals data dot split. And what am I going to use as the delimiter when I split? Tab. Okay. Now when I print data, remember it's a split. The return value of split is a list. So data should be a list and I should have all of those numbers. And I do. See that? Now I have a list with all the numbers. You see my bracket and you see the numbers. Now, notice that the numbers are strings. But that's what I want, okay? Because I'm using a palindrome function that accepts strings as an argument. So strings is what I want. If we wanted to, we could do a simple command and cast all of those strings into integers, and then you'd have integers. But we're not going to do that because we don't want to do that. We actually have the data in a form that we want now, okay? Because we want strings. So now, what am I going to do? I'm going to iterate through the list looking for palindromes. Now, I skipped a spot in the beginning of the program because I wanted to go back and do it now. What do I want to do? Put import tools. I wrote that library, okay? I'm not importing math or statistic. It's right here, tools.py. It's in the same directory as this program right here, and it's right there. That's my palindrome library called the tools.py, all right? Back to it in a moment. So I'm importing tools. So when I come down here, I want to iterate through my list. So I'm going to say for I in data. No need for range, no need for any craziness. If tools.isPal I equals true, what do I want to do? I want to print I want to say C is equal to 1, and I'll create the C. And I'm going to say A is equal to, I'll do the same thing here, but I'll do it with I. Okay? Now, where am I going wrong? There's one place I'm going wrong. I want to make sure that's an integer because I'm doing math with it. You're dealing with a string. You're sending a string down, it's true. Print a string, that's fine. Counter, that's fine. And we're dealing with our own numbers. Here, I'm going to want to cast it before I add it to my accumulator. Now, what's the other thing I want to do? I want to make sure that, I'll do it separately to keep it clear. 0, and there we go. Okay? So now I should iterate through that list, and every time there's a palindrome and it says true, I'll print it, I'll click that counter, and I'll accumulate it. So when I get to the end, I can print, capital, what am I thinking? I'll print, and then I'll just print a silly little line at first to separate us, the summary from the detail, and then I will print, there were C palindromes and they summed up to A. Okay? Let's run it. Let's see if we have some luck. Save F5. Look at that, nice little list. There were 24 palindromes and they summed up to 105,321. I have no earthly idea if that's correct. But as I look at the numbers that printed out along the way, I'm a pretty happy camper because what am I seeing? I'm seeing palindromes. Okay? 24 out of 1,000. That's not so bad. Okay? Single digit, always going to be a palindrome. So I guess there was only one single digit in that whole thing, which is kind of cool. Yeah, these are all palindromes. Okay? Look at the clock. 8:54. All right? When did we start? 8:39? 15 minutes. 15 minutes it took us to do our homework. Well, my homework. Okay? Think about it. Is my homework that much different than yours? Not really. You have an extra function because you need two. You need the Harshed and you need Siete, but think about it. It's really not that much. You do have to do a little bit of file I/O because you need to output the Harshed numbers with the 7 in the tens column. But other than that, I mean, we whipped this up in 15 minutes. Okay? And this is the whole tool chain right here. We created a palindrome library. I created a little variable, and I'll get to that in a second. Don't worry about it. But right here, I mean, this is it. I imported my own library that we created, tools.py. I read in the random number file. We created it right here while we were doing it. Read it in, cleaned the data, got it into a list, and then we iterated through that list using our palindrome function to see if something were a palindrome, keeping track of it with a counter and also accumulating. And then we printed our results. It's that simple. It really is that simple. It's not a difficult thing at all. But now, I'm going to save this. I'm going to get rid of it. And the point of this whole thing, new file, do that later. And let's say I'm just going to call this, oh, it'd be nice if Idle went and saved the last place you were. God forbid something actually works the way it should. I'll just call this test.py. And I'm going to import tools. And I'm going to say A equals race car. And B equals 112233. So that'll be false. And I'll say C equals string. Because remember, I need a string if I'm going to pass it to my isPal. And I will say string of tools.gooden. Okay? And I'm going to say print isPal A, isPal B, isPal C. And what will happen? That will blow up in my face because I need to tell it where to go get it. And yes, I know this is boring and rote, but I always put the library in front. I think it's a better way to call it. So this is look at that. Reads in my idle is reading in my library and telling me what I have. I have a constant and I have one function called isPal. Viva lay idle. And we see true, false, false. 16 is not a palindrome. Okay? Where's my test? 112233 is not a palindrome. Race car is a palindrome. So true, false, false. That's correct. The point being, I didn't have to write that palindrome code again. It was sitting there waiting for me. Do you see 16 anywhere in here? No. I read it as a constant from my library. Okay? I can use this library with any kind of, just by saying import tools and putting tools in front of my function calls. That's it. This library is done. Got that palindrome problem licked. We'll never have to worry about palindromes again because I have that code in my library. Okay? Code reuse, modularity. That's what we're talking about when we talk about modularity and compartmentalization in programming and code reuse. Okay? So that, let me Zot's test and bring back, oh, I'm going to have to read it back in. That's fine. Open Python for data science. Summer, Unit 3. I called it U3. All right. At the end of the day, this is your whole tool chain right here. Just a simple little library with that one function defined in it, and then a little constant variable, and then this simple piece of text right here. Clear, concise, commented, very brief, but we read in a file of 1,000 numbers, cleaned it up so we could get it in a list and iterate over it, and then we iterated over it using a function in a custom library that we wrote to tell us whether something is a palindrome. We counted them, we accumulated it, and we reported our results in the end. And we did it all in 15 minutes. Okay? Now you should be starting to get the idea that, you know, it's only been a month, but you guys have done a lot, and you guys have covered a lot. We've covered the basics of Python. Next unit, we're going to start using it. We're going to use it for computer science topics. We're going to use it for object orientation. We're going to use it for data structures. The basics of Python are basically in your brains already. Okay? Think about it. We just took random numbers, cleaned them up, read them in, and did something with them. I mean, as simple and goofy as the example is, it's a data science task. Okay? You were looking for a certain kind of number, and you winnowed 1,000 number file down to 24. And then you added up the numbers and manipulated them and learned something about them. There's some. So you're starting to get stuff done. You're starting to do it. And to go a level higher, that's what modularity is about. Modularity is about taking code that might get reused at a future date and putting it in a library. Modularity is about keeping your data in files because you want that data to be in a permanent store somewhere. You don't want it to be in RAM or in a program where it might get blown away or blah, blah, blah. You want your data in a file. So that's also compartmentalized in a way and different, and will always be there for you to read it. Then you could have like a main control program, like we have U3V3 here, that uses all of these tools and brings together all our different tools, and you use that to solve problems. All right? All right. I am going to get out of here. I'm going to hopefully produce this video tonight. It's the 29th, and I'm going to give it to you tonight. So you are going to have all of your resources for the unit 9 days before the end of the unit. And that makes me happy, and that's pretty cool. You got a full 9 days to read the book, reread the slides, watch all 3 of the Unit 3 videos, have a day or two to get that Harshed function working properly for assignment number 1, and then you tackle the big one. All right? You grab that number file, you clean it up, and then you examine it to find all the Harshed numbers, and you count them up and accumulate them, and then I would do it with another list. I don't know about you. You fill up a second list with just the Harsheds that you find, and then you run it through Siete, and you look for the numbers that have a 7 in the second column. And then when you find them, you write them to an output file, because that's what I want you to do with the output file. And then you're going to run that list, the Harsheds that have a 7 in the second column, against your constant and see if they're multiples of the constant. You'll tell me if there is any numbers in that list that are multiples of your constant. And that's it. It's not that hard. I mean, it's not that dissimilar to kind of what we did in the last 20, 25 minutes, or however long this video is. I don't even know when I started. All right? All right. I think you guys are in good shape. I think you're going to be fine. Do not sleep on the midterm project, because you've only got about maybe 2 more weeks. July 13th is a drop dead day for that. All right. Also, don't forget, in 2 days, I'm going to solidify groups. So if I don't get emails, I'm literally going right down the line alphabetically. And if you're not in a group, you're going in 1, and then 2, and then 3, blah, blah, blah. And then I will do emails to everybody telling them who their group members are. To be honest with you, that's fine. If that'll work, fine. I mean, you guys are all grown-up graduate students, serious, want to get the job done. I think we've got some talented programmers in the group, so I think we're going to be fine as far as final projects are concerned. Then I usually don't release the final project information while the midterm project is out there. But because of the time constraints of a summer session, I may do just that and release information about the final project to you maybe the beginning of next week. Promise me that you'll only read it and prepare a little bit, because I want you to do that midterm project. I want you to do Code Academy. I want you to watch those MIT lectures. I want you to learn Python the hard way. Okay? Because you know me, there's always a method behind the madness, right? I want you to practice. I want you to do all the extra practice. That's why you have this midterm assignment. I want to kind of know how you like to learn, because if you think about it, the 3 resources that you have to look at for your midterm project vary in different ways educationally, and we'll talk about it after. But I'm very curious to see like what you like, and whether you like sometimes, I'm not going to say anything. I'm going to let you decide, and then we'll talk about it afterwards. All right? So don't forget that. Word to the wise. It's 4th of July weekend coming up, okay? And it's the 4th is actually part of a 3-day weekend. So we're going to be barbecuing. We're going to be running around on bicycles and pools, blowing our hands up with fireworks, blah, blah, blah. So get some work done a couple days beforehand. Tomorrow, Friday, do the forum post. Do something to get things going. Get that Harshat assignment done. You don't have to hand it in, but get it done. So that when you're done with the 4th of July and it's July 4th, and you're like, oh crap, there's only 4 more days left in Unit 3, you're not driving yourself crazy. You've already got some work in the books. All right? Cave is going to be open Tuesday, the 5th, the 6th, the 7th. So if you want to come by the cave and you want some help with stuff, Jamie is there. She's my iLab assistant, and she's going to be helping people all summer long. So if you want to come to the cave and get some help, more than welcome. Love to see you. All right? Then I'm going to get out of here. You have a good night, and I'm sure I'm going to be chiming in the next couple of days. All right? And without a doubt, have a great Independence Day. It's a good holiday weekend. I can't wait. Isn't that terrible? It's Wednesday, and I just want to get to the weekend. I got work to do the next couple of days, though. I got to do it. All right. You be good. I'll talk to you later. Goodbye.